Any Linux bash gurus can you tell me how this works? Anybody? I mean, I get a general sense of what it's doing, but I don't really understand the syntax. Especially the whole, like this. Like, that's not, I don't think there's an opening one of those. Like, it's just hanging out there in the middle. And
that's everything else.
What?
That's everything else.
It's everything else?
Yeah.
It's part of the case statement?
Yes.
Yeah.
And that's why you have the back one. Because you had the back one in the first option, but two.
Oh, I see.
It's
like a pattern matching statement?
No, it's not matching.
Okay.
That's how it's done.
Alright.
But the first line is pattern matching, which is why.
Shell scripting goes back like very long time ago.
Oh, no, I get it.
And it's like somebody wanted it this way.
I just hate it.
Yeah. Well,
Like,
I'm saying there's a lot of baggage.
yes, there is a lot of baggage, and I hate all of it.
Yeah.
So whenever I have to, what was I doing the other day? I was trying to write a bash script because it was easy, right? And in bash, single quotes are different than double quotes. Single quotes don't give you the interpolation.
They don't understand wild characters.
And in Python, you use what you know. And so I'm in Python, and I'm banging my head against the wall trying to figure out why this. And it was like 2 hours later that I finally figured. Because you can't Google that, right? Like, it's really hard. Like, the problem I'm having is very specific, and so I'm just like, no, I have no idea that it has to do with the quotes. And
you got to be very careful about spacing. Sometimes if you use square brackets, you got to make sure the spaces are correct, because otherwise, because it's all pipelining, this is all filter pipeline and stuff. If you don't have the space, it thinks it's part of something else.
Yes.
Same thing. So.
And I hate it.
Yeah.
But I love Python. And at least most Linux systems these days are going to have Python on it. And if you're on Windows, you don't have Bash anyway. So I guess you could use PowerScript. But if you're using Python anyway, why not use Python? So my argument is, by default, Python is actually kind of verbose and cumbersome to do this type of scripting in, because getting a system call done correctly can be a pain in the butt. So we're going to look at some ways to basically make that a heck of a lot easier than what Python does by using a couple libraries. But we're going to walk ourselves through some of this. And so my goal here is to convince you to never again write a bash script and instead use Python. Any questions before we start? Okay. Notice the exit at the top. Anybody know why I might put the exit at the top? Give me a guess. I won't make fun of you if you're wrong, I promise.
So the window goes away?
What?
So the window goes away?
It's just because I didn't want to accidentally run this script and run the apt-get purge on the kernels. So I did accidentally run it because there was 2 scripts right next to each other, and I accidentally ran the wrong one. And so I just didn't want to run the script. So I thought about taking the sudo out of there, but then I was like, I'll forget to tell about it, that it's supposed to be there. So, okay, so has anybody looked at this yet and kind of figured out what it does?
It looks like it cleans up all packages that maybe aren't being used anymore.
Yeah, so not all packages. In particular, it cleans up the Linux kernel. So in Ubuntu, you will continue to get a Linux kernel updates. And if you have a boot partition that's separate from the rest of your root hard drive, your boot partition can fill up. It's because there's a whole bunch. There's the Linux image files. There's the init.rd files in there, or it's not the right name. That's it. All right. The init.rd image files. I forget exactly what they're for, but it's basically part of it's an initial file system that the kernel needs to boot, and I'm not even sure why, but they're all in there and they all pile up, and your boot system fills up, and then you've got problems because your kernel installs fail and you don't get new kernels. So this command is something I found out in a Stack Overflow or something in order to basically clean up all of the old kernels except for the one that's running. The idea being, if you are running in that kernel, it's stable and it's okay to clear out the old ones. That's actually not true, and I spent 6 hours yesterday fixing my laptop because this assumption failed, and I now have a new command that I use, but we won't talk about that right now. But tell you what, perfect storm of events made me clear out all the good kernels that I had. Okay, so let's talk about what this does. We're going to actually start on the right-hand side. And we're going to pull up uname-r. Oh, that's not what I'm going to do. So let's see if I can get a... Yeah. uname-r. So in Linux, uname-r gives me the version of the kernel that's running. So I'm running 4.4.0-71-generic, and that's helpful because that ends up being part of the string that's the packages that we want to keep. So I'm just going to kind of walk you through these commands here so you can kind of see them operating. Anybody want to guess what the sed does?
It's a replace.
What's it going to do? It's going to take everything that's not, or that is A through Z,
Yes, it's not.
and knock it off. So it's just going to leave us numbers and dashes, I think. Yep. Okay? And so then that's going to get passed. So this dollar syntax here is the bash way to basically run a subcommand and use that output in the command. So we're not piping here. This is just going to give me a string that's going to become part of the next command. So the next command is going to be grep-ve 4.4.0-71, and it's going to receive the result of this awk command, which is going to receive the result of this dpackage command. And then the result of all of that, once again, you got this dollar sign, is going to get fed to apt-get purge. So ultimately, we're going to call, I guess let me walk this back a little bit. I'll take all of this. Well, let me build it up the other way, and then you can see it. So you're going to see, you see with that value at the end. So this is giving me columns. I've got the package name, I've got the actual package version, and I've got some other stuff that I don't care about. These two characters at the beginning tell me what the status of that package is. II means installed, RC means something that I don't care about. It means not installed. So then I'm going to pipe that through awk. Anybody can tell me what the awk's going to do? So awk is going to,
Prints the second column.
it prints the second column, and it is going to filter for those things that start with II. So I'm going to result with just installed packages. Everybody understand how we got there? Any questions? If you're lost now, let me know, because you're going to be lost for the rest of the evening. Okay? So now, remember what we got from uname-r? We got a kernel. We got our current kernel version. So what do you think grep-ve is going to do? So we got to list all the packages. We got a current kernel version.
It will filter it to list only those that doesn't have this.
That's right. The -v inverts grep. Usually grep would give you the things that match. -v inverts it. So basically, we're going to end up filtering out our current kernel package because we don't want to uninstall all of our kernels. That would be bad. That's kind of the definition of a messed up system. All right, so I'm just going to write the grep, and I'm going to fill in the value we got earlier from the uname-r command. And you'll notice that now the last item here is no longer 7.9. It was before. If we scroll up, this is the package that is our current kernel version. Oh, and our headers are in there too. And you'll notice now the headers are gone too. So we filtered out both packages relating to the current version that we're running of the kernel. Any questions on that? Pretty straightforward once you understand it and you can walk through it. Pretty crazy though when you're looking at it, right? You have to walk through, run the commands, understand each little bit of it. Otherwise, there's no way to just look at that unless you're doing bash scripting all the time, right? And you're familiar with these commands. There's nothing user-friendly about it. And there's no way to put comments in here. I guess you could, maybe if this was a script, you could comment all of them, but you can't put comments in the middle and explain what's going on. So it's just not developer-friendly in my opinion. All right. So let's look at our first attempt. So what's our first attempt to run in Python? Well, my first attempt to run in Python is to just get that very first command to work. Right? This is what we ran. This here. And I just want to I'm just trying to, agile approach my way out. I just want one thing to run. Notice that I didn't run the purge command. I'm just going to leave the purge command out at this point, and all we're going to do is try to list it because it would just be another pipe. So actually, it wouldn't be a pipe. It would be the shell taking all of those values and basically putting spaces between them and feeding them on the command line to apt-get purge. But we're not going to worry about that for now. So first option here, fantastic. So this is literally like I walked through this 3 times. Like it took me probably 30 minutes to figure out what was wrong here. I'm not going to tell you right away. But this is, and so I'm going, okay. Did anybody know what the problem is? Because I don't get this problem if I run the command on the command line. What?
String format?
I think it's like the regex is not
It's on Turkey.
calculated on the fly if you run it this way because it's a bash. So I think I'm not sure if you run the command using this OS system if it actually goes through the bash processing.
Yes. So I think for os.system it does, but it doesn't. You're really close. It's because bash is actually interpreting. So it took me a long time to figure this out, a lot longer than it should have. But this part right here is not actually a feature. The dash, this part is the 0 through 9 and the star are part of dpackage query, which is what dpackage is feeding this to. But this part is actually coming from bash. How do you know that?
Oh.
I don't know that. So here, let me show you how I know this. You know how I figured it out? I ran this. And I realized, you know what, that's bash doing it. And then I ran and I realized at that point what it was doing. Did I tell you I hate bash scripting?
That's why people went to Perl. Can you believe that?
Yes, actually I can. Yes. I used Perl back in the day. It was good stuff. I actually liked Perl for a while. It just kind of lost. I don't know why it lost, but it lost. I think it lost to PHP and then it lost to Python, at least for me.
You never got object-oriented.
Is that what it was?
Yeah. Never got it there.
Okay, so the reason this isn't working is because dpackage is actually running this with the whole brackets and the comma and everything, and there's just no packages. It's responding correctly. There are no packages like that. And I kind of ruined my surprise because that took me to. So I tried. Okay, so I thought maybe it was the os.system thing, and I tried running it through the shell. Yeah, this didn't work either. And then I thought, okay, I'm going to actually break this up and use the. So rather than using the shell command here, I'm going to drop down the sub process and actually put it into arguments, thinking that might have been the problem, and it wasn't. And so I'm pretty irritated at this point because I'm supposed to teach this stuff, right? Like, it's like, this is exactly why I hate this. So anyway, so we got to 0-4 pretty quickly. This is going to be a short night. We're going a lot faster than I thought. So anyway, I finally got this to run. So, it's so funny. Oh.
It's called Randy?
No, it's that I'm not in my virtual environment. I created it in the terminal earlier, but I just want. So the reason is because Python the .run method on sub process is a Python 3, feature in the Python I was using earlier was Python 2. So now that I'm in my virtual environment, which I set up previously to be Python 3, now it'll work correctly. All right, so now this looks very familiar to what we got previously, right? And it should, because by default, the .run method is going to hook the output of any of the commands that you run to the output, to the standard out of the program that you're running, and it's just gonna output it, just like Bash would. By default, it's gonna put the standard out in the terminal that you ran the Python script from. Okay, so same output, and then at the very end there, you'll see I've got this completed process object, and that is the thing that .run is returning to me. And so it tells me what my command was. It gives me my return code. By default, it does not capture standard out or standard error. Those just get passed through. There's some other commands that you can use in the subprocess module that will check the error code for you. So if it's anything but 0, it'll automatically throw an exception. Because like by default, if you have a command that exits with a 1 and maybe puts some output on standard out, and you're using on standard error, and you don't check that value, well then your chain kind of continues to run like there's no exception by default. And so that's one of another disadvantages of using subprocessors. There's a lot to think about what's going on sometimes. There's some other calls you can use. Subprocess.checkCall will automatically throw an exception if you don't hit 0. So there's some other stuff in the module to help. But it's kind of, you really got to like read through there and understand what's going on. You can't just kind of grab the .run and use it, which can make scripting like this kind of difficult. Any questions so far? All right. Okay, so with this command, what I'm trying to do now is I want to capture that standard out rather than have it automatically get piped to my terminal standard out. I want to do something with it now. And so the only real difference here is first I've moved the arguments out to make them just a little bit more manageable, and then I've added subprocess.pipe to the standard out keyword arg to run. And so now if I run this, you'll see that I don't get any output.
But there is a checkout command. There is a subprocess.checkout which will give you the output. Yes. There's lots of different commands. There's the check something, which won't give you the output. There's check output, which will. So there's some different helper functions, but I'm just kind of showing you what happens without those extras, if you will. Now, if I want to get hold of that, and I print this result, you'll see that I get a whole bunch of stuff. And if we go all the way to the top, that's because that completed process, now you have the args like you did before, and you have the return code, but now you also have a standard out attribute on it, which is now the standard out of the command that you ran. So if I wanted to get the first line, now somebody tell me what this means. That's kind of important for us. We're in Python 3 world. What does that mean?
Bytes.
It's bytes as opposed to strings. Yep. And so in Python 2, this was kind of, you transfer back and forth really quickly. Now think about it. In Python 3, it's different. So when I get the result, I'm actually going to take and I am going to decode. This is always opposite for me. I decode the bytes, and then I want to, now I've got a string, so I'm going to strip the string to get the new lines off the end, and I'm going to, oh, this isn't right. There we go. And so I'm going to do standard out lines. So I just want to get the first line here is all I'm trying to do, to get rid of some of that output. And that was the top of the command. So if I wanted to, I could do different stuff with this standard out. I could get the standard error if I wanted to. I can check the return code if I want to. So I have some flexibility here.
And also pipe the standard error to the standard out if you're trying just to capture one.
I could. Yep, that's right. I could get it all into one stream. And if I did that, it would look like standard error equals subprocess dot standard out. Is that right? I think is what you do here. And so then they would both end up being in standard out. Questions so far? Okay, so now what we're going to do is we're going to just do one sequence of commands or one chain call here is what we're trying to do. And so we're taking the same argument that we had before, except we're not calling .run anymore. We're starting to work with some of the primitives, some of the things that run is working with underneath the hood, which is this popen class, process open. And so I'm passing in my args, I'm setting the standard out to pipe again. But now I'm creating a second popen instance with my awk arguments. Now this awk string is the same as we saw earlier. It's the same as what's in here. Let's keep this one open. Open that back up. So awk I print 2. Awk I print 2, it's the same thing, feeding that to the popen instance. Now this is important, the Python docs say that this is important. I struggled to understand how this works because the popens aren't actually running until you call awk.communicate down here. And so I don't understand how the how standard in is going to use the standard out if I've closed it. That doesn't make sense to me, but the doc say I'm supposed to do it that way, so I did, but it's something that I wanted to research but didn't have time.
It's like a screen sort of thing, you know, so you're telling it to close, but it's not processed yet. It's just like the order of operations close after that, you know.
Yeah, but it would seem like this applies now.
Right. It looks like it. That would be used to thinking that kind of thing. You're right.
So
I don't know if maybe it just keeps a handle.
So you mean it's like putting close at the end of the string precisely?
Yeah, I mean, you know, I worked with strings a little bit when I did some JavaScript node stuff, and you know, it feels very much like you're setting up a string endpoints to just like string from something that's pooping out a bunch of information. You want to feed into another thing, and you set it up like that. And you want to close a string, and you tell it to do that in the right order, but then you run it, like you is kind of distinct from setting up your orders.
Yeah, so the close distinct from the running is just where, like, my conceptual, yeah.
So what you're saying is none of the stuff up there happens until awk communicate?
That's sort of, yeah. It evaluates the different.
So I wonder if maybe under the hood, the standard out is not just like a byte stream, because like on a typical bytes IO object, you call close to done. So maybe this is some type of special.
Did you have to close it like because you're calling it as part of the popen awk command for your standard in, or did it just say close it just because?
So it said I had to close it because if I didn't, and the awk command exited, the first process would not receive a sig pipe like it should.
Is that because your standard in and awk is pointing at dpackage.standard out?
Yes, so this is required because I'm basically setting up the pipe. So here, what I'm doing in Python is basically this. So I'm setting up that pipe, one process to another.
Right, but I guess what I'm saying is because in dpackage, when you call it, like when you do the dpackage
Here?
equals popen and that starts running.
It doesn't, that's the point. It doesn't start running
not
here.
running until awk calls it.
It's not running until this, yeah, so somehow this communicate on awk actually starts the dpackage command running. No activity actually is done. This is just kind of a placeholder at this point. Which would make, if it did, then it would make sense, right? I've ran them both and now I'm closing it, but it's, so I'm curious. I wonder what
Be careful because you might be initiating
yeah, we'll
the
see
running a depackage.
if we break something here. It is buffered reader.
Okay.
All right. Well, anyway, I digress, obviously. So what I've done here is I've taken my dpackage command, I've created the process open instance, I've created the awk command, I've fed the dpackage output to the awk input, standard in. I've done my .close thingy, and now the awk.communicate is where the work actually gets done. Let me prove that. Oh, I'm wrong. Look at that.
So, I guess what I was meaning earlier was, if depackage, you're not calling subprocess. So if it kind of kicks in and it's writing the standard out, and then you don't close standard out and you start feeding that to in, does it know, like, is it a generator that's actually going to stream that, or are you closing the standard out because you're feeding it over to this new in? And so, like, the way those streams interact, that's why you're closing it early, is you're getting ready to feed it to this new awk call into the in. So you need to close it, now you've got that, and you're shoving it into the
I guess so. I think because like this is actually surprising to me. So I guess I was wrong. When I said that this does not kick off dpackage right away, I must be wrong on that.
If you did, like, if you were doing a sub process, you would have to call like .start or something. Like, but since you're just doing a p open, that is supposed to kick off right away.
Okay. Well, that's obviously my misunderstanding. So this awk.communicate must be just a just part of the whole streaming back and forth thing. Like, I don't really know. So that's surprising to me.
So if we added another pipe to that, would we have to kind of, like, let's say we added another popen call after off, like we're going to call something else. I mean, in this case, what are we calling it? We're actually being added to something.
Yeah, we'll actually gonna do that next.
Okay. So you're probably going to have to do the same thing then, right? With the close.
Yep, you're just gonna keep you're just gonna keep kind of repeating what we just did. So any questions about this? I have questions about this. It works. I followed the directions. All right. Just make this a little smaller. Okay, so going back to kernel cleanup, remember that at the end, we kind of started, when we first started this, we started off with uname-r, and then we fed it through sed to kind of get our value that would then be part of the call to grep, not part of the piping process. So we're actually going to do that now. We're going to do that stuff first. So just like we did in the kernel cleanup script, we're going to get our kernel version first. So we call uname, and we pass uname standard in, standard out to sed standard in. We make sure that we get a pipe this time from sed because we're going to do some stuff here with the output. So once again, following the directions on calling .close, .communicate gives me standard out and standard error. So I take standard out, which is a byte stream, decode it to TF8, and strip it to get rid of that new line that it'll have on the end. And that gives me my kernel version. So make sense? Any questions about that? All right. So then we're going to do the dpackage and the awk, which we just did. Difference here, we're going to go ahead, rather than having it go to standard out, we're going to pipe it so that we can get a hold of the output. Now we're going to send it to grep, Notice that that kernel version ended up here in our command line arguments, not as part of the stream, either stream. Take the awk output, feed it to standard in. Once again, we want the piped output so we can do something with it later. Close dpackage and awk. Call grep.communicate. Take the standard out there, decode strip dance and strip dance. That's yeah. Yes, that's. Is it right? No, that's not right. Why is that not right? So we should have filtered out. Kernel is 7. Should have filtered out.
The 7.1 is your actual running version right now. I noticed that earlier. Right?
Look at that.
You weren't deleting it, so I decided to.
No, that was good. That's a good call. Huh. All right. Well, I should be running 7.9. Why is it running the earliest version, not the latest? All right. Okay, so 7.71 or -7.1 is stripped out instead. That's great. Thanks for pointing that out because I would have been very confused there for a while. Any questions about this? What do you think? Is this easy to read? Have we made any real progress over the bash version?
You still have the bash strings to build.
Do what?
You still have to know the bash.
Yeah.
That's
This is
exactly what I was going to say.
Yeah. You haven't really.
This doesn't help me at all.
It's not really helping at all. No. So why are we doing this?
To show the background.
Yeah, just to show some background, right? Kind of show you why you might not want to do it this way. Now, there's reasons. There's reasons why you might want to interact with sub processes this way or other processes, but this just isn't that user friendly off the bat. And a lot of it is that we still have to know the bash commands. Whoever said that, but a lot of the other part of it is that working with the typical Python sub process module is a bit verbose. And you really kind of got to know what's going on. It's not as easy as just, I might know the bash command, in which case I want to use it, right? Because there's sometimes where I know exactly how to do this in bash. I really don't, it would be really easy to do. I don't necessarily want to convert it. It's not an application, it's just a script, right? I want to use what I know. So I could use it this way, but it's still kind of verbose, not very user-friendly. I'm not sure I've gained a whole lot here. So let's see what else we can do. Yeah.
Actually, 2 of the commands doesn't have to be bash, just like I said, you can replace it with normal Python stuff. And
You can, and we will get there. Yep.
okay.
We are making progress. All right, so okay, so now we're going to use a library called Plumbum, and Plumbum is a library that's made specifically to help with the syntax and ease of use when doing sub-process calls. And so in Plumbum, you can import from this special command module, and this is not actually a Python module. They're doing some import hooks to actually look in your path and find the binaries. So when I import these things, these represent Plumbum objects that internally inside of them know that I'm referring to the uname binary, the set binary, the grep binary, the awk binary, and so these are not like Python modules that Plumbum is providing. These are actually calling, these are doing the same thing that we did in the last example. It's calling the system calls. And so Plumbum has a very, if you're familiar with the command line with bash, it looks very similar, right? Where in order to do a pipe, you use a pipe symbol. And you create your chain this way. This is a little bit unnatural. The chain in Plumbum is kind of created and then it has to be used. And so you'll see that I'm doing that here. I create the chain first, I kind of display it. I'll show you why I do that. You can just kind of see what the chain is made of. And then the kernel version actually comes from executing the chain, and then I go ahead and it's doing some of the binary conversion for me to give me a string, and so then I strip that. And then I create another chain for dpackage. So same stuff I did before. Dpackage gives me all the lists, pipe it through awk, take just the installed ones, take the second position to get the package name, and to run it through grep. once again, passing in the kernel version that I got from the earlier commands. So call that chain, call chain 2, strip the result, and you end up with packages. So let's take a look at that.
So the pipe like that is a bitwise OR, right?
It is a bitwise OR. So
does it know what to do with that, or is there some weird?
yeah, so in Python, all operators are actually translated to calls on the class. And so the Python class objects,
The magic method.
So there's a bitwise, just like there's an add and a multiply and a divide, and there's all kinds of them.
Right.
But there's one for bitwise operations. So what they've done on whatever this class is that these things represent, they have bitwise OR methods set up that then know how to basically chain those actual calls together and do something with them.
That's actually pretty clever.
Okay, 08. Okay, and so we see same thing as before. We've got .7 or -7.1 being filtered out, and we get the rest of our packages for cleanup here. Questions about this? Improvement? I think so. Now, once again, if I'm going to do it all when using awk and sed, why would I do this? Well, it may be that maybe I have a script that I want to enhance. I eventually want to convert it to Python, but right now I just need to kind of start incrementally doing it. So if I know the script works, I can pretty closely match everything that's there. And then I can slowly, incrementally, maybe build more of it into Python and remove some of the system calls.
I think the gain is not super visible yet because the logic is pretty sequential. If the logic would become more branched, then bash would go crazy.
Yeah. So I tried to keep it simple, but yeah. So and I hate once again like bash if else statements. You got to remember to put the colon in there or the semicolon. Like it's crazy.
And so if you have you want to use the bash commands, but the logic is much more complex with some checks and different conditions, then it will definitely be better.
Yeah. So I didn't go into that, but you're right because I'm very used to the Python logic structures. I'm very used to Python loops. I don't have to have a whole nother syntax to understand. And so you're right. I could have probably picked some better examples that would have demonstrated a bit of the power of Python. Okay, so this is Plumbum. Plumbum works on Windows. There is another library called.
There's funny thing about this because actually these brackets it's also a overloaded operator.
Yes, that's correct.
And it's funny because if you use brackets, it creates an object that can be piped, but if you use the parents, it actually calls it.
It executes. Yep.
Nice.
Yep. You're right. So that's more operator overloading. Okay, so we got, and actually it may not actually be operator overloading. It's because the operators themselves aren't changing. But whatever.
Yeah, it's not overloading.
Okay, so this is SH. So we're doing a very similar thing here. SH, you don't have to, by default, if you import from it, you don't have the .command thing like you did in Plumbum because SH is a single file. That's the other reason I like SH because it's actually just a single file. If you had to distribute a script, you could actually distribute SH right next to it and import, relatively speaking, to whatever that script is, and it would work. So you'd have kind of a two-file deploy, but it's Linux only. So that would also could be a hindrance. Although a lot of times if you're doing scripting like this, it's going to be pretty OS specific anyway. Pretty much the same thing here. The big difference is rather than using the pipe character, SH uses functional composition. So I guess that's not right either, but it's taking the result from each one of these arguments and using it as the first argument to the next one. Which I actually, as I did this, I like the pipe easier. Like if I'm doing scripting like this, the piping makes a little bit more sense to me. It's a little bit more intuitive. Kind of having to do all these like this was not as intuitive. But they, like SH or like Plumbum had the brackets, SH has a .bake command, which if called will basically prep all of the arguments but not call it and let you kind of set up your commands. So I could set up all my commands in, you know, like 3 lines and then just kind of feed them all to each other using .bake. Or I would set them up with .bake and then I would feed them all to each other in quick succession. It would be one command right after another. It would be really easy to understand what was going on. This is kind of interesting though too. So apparently this depackage command adjusts its output based on how wide your terminal is. And for some reason, however Plumbum works, it worked great. But however, whatever SH is doing, it thought I had an 80 character terminal and it was cutting off the output. And so it was really frustrating. You didn't end up seeing the same output. So I had to feed an environment variable here to the depackage command. But once again, that makes it's kind of showing it's pretty easy to do. So I'll run this just to show that it works. And once again, no 7 ones, we got everything else. Okay, so, but once again, these are all still just bash commands. You got to know the system commands. If you had something kind of complicated, you'd have to know all the different switches. And it's just a pain in the butt. So let's look at 10. So what I've done with 10 here is I've switched to uname and depackage are now the only system commands that I'm using. I'm going to keep those. It's kind of hard. I probably could figure out a way to get, I could actually open up this special file here if I wanted to and read the kernel version if I didn't want to use uname. And I could probably figure out how depackage gets its information to it myself. But you got the system call. That's why we're doing it, right? If we could do all this in Python, then this wouldn't be a demo. So we still got some system commands that we're using. You've already seen this code before. We're just trying to get the kernel version. We have the depackage command, and we're just turning that into a list of strings at this point. Oh, that's not helpful. Once I have the list of strings, I'm doing a little functional programming here. So I'm filtering down to the line that starts with II. So this replaces what? What command did this for us earlier? Awk did. That was the first part of what awk did. And then this split is doing the second part of what awk did. It's splitting on white space. And then it's taking the second. So awk said print 2. Awk is 1 indexed. Our Python's lists are 0 indexed, so that's why you see the difference between the 2 and the 1. And so I'm looping through all of those lines. I'm splitting them, and I'm taking the second column. So this ends up being a list of strings with package names in them. I'm creating another filter, and I'm basically just making sure that I filter out any lines that have the kernel version in there. And then I'm joining at the very end, since that's a list, I'm just joining on a new line to give me a string with new lines, just like the output we were seeing previously. So same stuff. Okay, questions about this? What are we missing?
Actual purge?
The what?
The actual purge.
We are missing the purge. That's not what I'm talking about. But it was a good guess. It was a correct guess. Just not what I was looking for. Anybody? What are we missing? What are we missing, Nate?
I'm not sure. What?
Error checking.
Yeah, well, maybe some error checking, yeah.
Oh, tests?
Tests! We're missing tests! Oh my goodness. None of this is tested, right?
I knew that's what he wanted. I
Yeah.
just refused to say it.
You just did the manual test.
How do you test this? Can you test this very easily?
You should probably simulate the behavior of bash commands somehow.
You use like mock, which is
Anyway,
It's the only real way to do this one. Test this one. I don't know if you caught it, but I moved back one. I moved to 9. So everything would basically have to be mocked, because otherwise you're actually making real system calls. Which I guess you could do maybe for like the awk, but you can't do it for the uname, you can't do it for the depackage. So let's look at what tests would look like. So this is, the first thing I did was I moved filter packages. I moved the code that was basically kind of here, and I moved that into a function. Why did I do that? Why did I move that into a function?
Well, because then you can put a DerbyPy output, you know, test.
Yeah, easier to test.
Easier to test. Yep. It's just because it's easier to test. If I wanted to, let's say that this was a lot more complicated. This was a lot bigger part of my program. And the system calls I was making were relatively small compared to everything else I'm doing. If I promote that I/O to kind of the outside, if you think about the inside of your program and these concentric circles, if I have all that I/O on the outside and make everything else kind of on the inside, then that means I can just feed strings and typical Python objects, and I can probably get 95% test coverage of my code and not have to mock anything. That's a win for me. If I'm doing some scripting and I just want to make sure that my logic running through the middle it works, and I'm pretty sure that my code to actually call the system commands is solid, and if I can get 95% test coverage, that's really good. So that's the first reason, right? I want as much as possible, get all that I/O, get all those system interactions kind of on the outside, put everything else on the inside, make it easy to test. Does everybody understand that? Anybody have a question about that? Or why we would do that, or how you do that in real life? It's a really important concept. If you have a really big legacy code base that's really hard to test for some reason, you can start doing this. You can basically start creating a bubble where you've got a thin layer on the outside that can't be tested, but you've got almost everything else in the middle rearranged so that you can test it, and all your stuff on the outside just calls into that stuff, which is where most of the work happens. Really powerful concept. Okay, so I create some tests now. Test installed filter. So basically I'm making sure that if I have an RC and an II, and this is -11 and this is -12, I want to run that through filter packages, and I want to make sure that -12 is the only thing that's left. And I want to make sure that my version filter also takes effect. So if I've got a -11 and a -12 and they're both installed, if I pass in -11 as my current kernel, I want to make sure that that's the one that gets filtered out and I'm left with -12. Okay, so then how do we test main, right? So I moved this into main. Now I'm calling, does everybody know what this is here, what I'm doing here? Who doesn't know? Somebody that doesn't know. Anybody?
I have no idea.
All right, there we go. I don't actually know what this is called, but the underscore name ends up resolving to the module that this Python script is. If you were in a bigger package, this might be like mypackage.libs.system interaction or something. So it would be a dotted path, and it would represent where the file is in my package. But when you have just a script and you're running it directly, this .name resolves to __ main. And so basically, this main call is only going to run if I execute this script. But if I run my tests, it will not run. So it won't actually execute it, only my tests will run. So basically, it's a way to kind of put something, it's basically the start point of the script. Like when I call this, because I remember I moved all of my code into main, and so if I just call this like this, nothing happens. It'll process all of my objects, my functions are created, but there's nothing actually kicking off that main function to actually work. But if I leave this in there, then that main is actually going to kick off because __ name is __ main.
But
Dunder.
you could
Dunder
just
something is what they call that.
you could just call main and you'd be able to run it without that. The problem would be if you wanted to import this somewhere else.
Not just import this because I've got tests.
Okay.
So if I ran my tests, so when I do py.test kernel list 11, right now that doesn't run. If I just had this, then it's going to run. Even though I really just want my test to run, it's going to actually execute the command, which would be bad if I didn't actually want the command to run, right? Okay, so I've got my filter packages test, and obviously that would grow as your function did more. But then I also figured, why not? Let's go ahead and test the main method too. Let's make sure that I glued it all together. And so I used mock for that. Mock.patch is basically going to go into this object, into this module as it's running in Python, and it's going to replace the print, uname, and dpackage global variables with mock objects. Mock objects are really flexible objects that you can kind of manipulate to do with whatever you want. So the first thing that I do is I take the dpackage object and I give it output to return that would match what you would get from the command if you ran it. And then I do the same for uname. I give it a return value complete with new line character, which is what it would get. That's what you would actually get if you remember we call strip on it to strip that new line out. And then I actually call main. And main, when it calls dpackage, so this, when I call that main in the tests, dpackage is no longer dpackage. Dpackage is now a mock object. But I'm setting it all up so that it works correctly. Then at the very end, I've also mocked out my print, and I'm going to make sure that my print was called with the correct arguments as well. And there's going to be two of them. There's going to be the kernel version 1, and there's going to be, for this test, there was only 2 lines. The -11 got filtered out, and so that's just going to leave the -12 as the one that should be removed. And PyTest is really cool. All I need is that, and it will automatically, because this starts with the word test and this starts with the word test, it will just automatically run those objects only. It's all based on kind of a naming convention. That's how PyTest knows what tests to run. And I think I ran those already, didn't I? Yeah. So I've got main doesn't run anymore, my tests do. Make sense? Any questions? That's all I really got for tonight. I feel bad.
Question for you, why don't you like mock? You mentioned before that you did not like mock.
No, I didn't mention.
So maybe you did.
No, I think it's cool. Actually, I never use mock. So far, because I'm writing mostly tests itself. So I don't test my tests, but it's a good idea. And actually, it's a good idea to actually mock those commands. Pretty good idea. Oh, I have a question.
Sure.
Because is it possible to call those bash commands on a remote machine somehow? I mean, because usually you do operations like scripts when SSH there, so maybe there's some support here to do it.
So not in SSH there, or not in SH there is, but in Plumbum they have a remote. From plumbum.remote import whatever, and then you kind of set up your SSH, and you basically do that. So it'll handle kind of the SSH negotiation. Which the nice thing would be if you could then mock that out, and then you can test all that stuff locally. You can have good tests, you can test exceptions, you can test network exceptions, and you can do all that stuff and make sure it's right. And then execute it, and it'll actually execute over SSH. There's also, it seems like there's another Python library, I can't remember the name of it. Does Fabric execute remote commands? There's another one, I think it's called Fabric. You could look into Fabric.
Yeah, Fabric is this as a Paramiko or something?
And Paramiko uses Paramiko. So maybe, I've done it directly with Paramiko, I think.
Yeah.
I'm not actually sure what Fabric does then.
So it's like Paramiko, and then you just construct this bash command somehow, which is like not very, readable.
Okay.
Actually.
We've actually,
seems much.
We've moved to using Ansible for a lot of like remote scripting, but you can't test Ansible very well. I kind of hate that about it. We just had something break the other day that was really frustrating.
I mean, part of our testing is running system commands
on remote systems.
Like node tool from Cassandra with different parameters, or dealing with files directories, like checking output of the command,
Sure.
like grabbing. So it's really helpful there.
Yeah, I would check out PlumBum because it had direct command for
those
SSH.
Really helpful stuff.
Anybody else?
But, so I'm kind of forgetting a little bit how best to approach this in Python, but like with parallel computing and putting things in the background and things.
So both of the libraries, both PlumBum and SH, I'm pretty sure had support for backgrounding the processes.
Okay.
I didn't do any of that, obviously, but you can. The other thing to know is that at least on SH, the commands, when you nest them like that, they're all executing sequentially. They're not feeding the streams as kind of in real time. And so there's a special command that you can basically set up on the inner one to say start yielding your output. And so that was really important. That's something if you wanted to do like a tail-f on a file to kind of always see what was coming. That internal command would never exit if you didn't run that command. So that's SH is really a powerful library and pretty simple, and the documentation is really good. I mean, you can just go there. They talk about specifically that use case in piping. They talk about basic and advanced piping, and the advanced is basically just you got to know if you need to start yielding your output, and if you do, you add this extra keyword argument. That's it. I didn't see PlumBum mention that. Documentation is a little bit more scattered, but you can kind of figure stuff out. Well, that's all I got. I'm happy to, if anybody want to take the presentation here and do like, what do they call them? The little fire
Lightning talk?
Lightning talk? Anybody want to give a lightning talk on something? We got a little bit of time. Usually I'm off to like 8:30, 8:45. I gypped you a little bit tonight. Anybody excited about that? They get to leave early? I won't blame you at all. I would be excited about that, except tonight I gotta go pick up my daughter from play practice at 9, so I'm just hanging around anyway. There's this thing called Clarksville Little Theater, and I don't know, she got somehow hooked up there, and it's kind of, she's a flower, and so she kind of sings and dances, and we've spent a whole bunch of time driving her in to do it.
I have a question.
Sure.
Looking at this code now, do you have any convention when you use filter and when you use this, I don't know the word,
these things, list comprehensions?
Yeah, list comprehension versus filtering. Because actually, the whole stuff can be one list comprehension.
Yep.
You can add it, but it seems like I can imagine that maybe you use filtering when you don't convert the result. Actually, like only filtering, and you use the list comprehension. If you change, like kind of a map. Yes.
Like what?
Like map.
A map, yes.
Yeah.
So the reason I don't use map is because, well, actually, here it doesn't really make sense. I probably was doing this in sequence, and so the reason I don't like map is it doesn't give me a list. It gives me a generator object.
Yeah,
and so
yeah,
if I ever want to print it, just kind of see what I'm doing, I always got to remember to call list. So sometimes I do list comprehensions just because I really want a list. Where I could have used a map, I could have used a bunch of filters in a map if I wanted to stream it all together. I just find that when I'm debugging, it's a lot harder to figure out what's actually going on because I got to remember to do the list. So I don't know that there's a convention. I used to do all this stuff with for loops, but I've started to kind of like the more functional.
Yeah, I want like, because it's can be like implies your package name is line split, blah 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 for line and instead lines. If line starts with, yes, this has this again. So the inside line can be removed, yes.
So there is no, list comprehensions don't support they don't have that filtering capability on the back. They do?
Yes. Maybe I'm wrong, but I'm pretty sure they are.
So you're saying that?
Yes, yes.
Yeah.
And that will work.
Super test break.
What?
I said you can see the test break. But that's on the wrong one.
There you go. I looked that up actually, and I got misled by Stack Overflow.
Well, Stack Overflow, I've noticed, has a lot of opinions about list comprehensions because we do that in some of our code, and there's a lot of people that are like, this is the Antichrist of list comprehension. It's like, they absolutely hate it. I'm just like, it's an if statement.
Yeah, no, I like.
I get
No,
it.
there's not an else here, is there? There's no else here.
No.
Okay.
You get it if, like, you know, you shove 3 comprehensions in there and you've got them within each one and stuff, like, starts getting excessive.
Yeah. The other reason I kind of did it this other way is because it's just, I think it's more readable. Like, that one's actually pretty simple, but like I'm naming all my variables, and so it's really kind of self-documenting, right? Like I might not know what the II does. Why is II there? But now I've got a variable called installed lines, and now I have a little hint there that okay, this is the II means it's installed. So I mean, you could easily put a little comment there, and that would tell you what you were doing. So I don't know that it's that big a deal. The guy that I was talking about earlier that was really into functional programming, he was really big into having kind of like variables and just chains of variables that at every step would basically tell you what you were doing. And in Haskell, all that stuff's lazy, so you're not executing it. And like your lambdas and your maps and all that stuff, they're all lazy, so they're not actually executing until they're finally called, and then it kind of walks back up the chain. So it doesn't cost you a whole lot to do that. And it does make it pretty easy to reason about what's going on there. You got a lot of context to help you. And everything is doing just kind of one thing, which can be helpful.
Do you ever do stuff like this at level 12, where you're writing bash scripts in Python, basically?
Yeah. Almost everything that I teach here is because I got sucked into it within the last month.
Okay. So when you do that, are you using these modules like SH or Plumbum, or are you
Yes.
just putting those into a shell script outside of your Python? Because I'm looking at number 10 here, and I'm thinking, okay, there's still a lot of bash that I have to know, but we did get rid of sed and awk, which I hate those in bash.
I mean, there's not a lot of bash. You don't need it. You don't really have any bash. You've got dpackage and uname.
No, it's not a complaint or a criticism. I'm just trying to think, if I was doing this, if I were doing this, would I put it all into one Python file, or would I just get rid of sed and awk and put that in Python, and then take the output of that and run that against a shell script?
Why would you not use sed and awk inside the Python script like I just did with Plumbum or SH?
No, I'm saying I would put uname and dpackage in the shell script, and then call my Python, or one way or the other. That's what I'm trying to sort. That's what I'm trying to.
My
figure
question is why you're asking the question, which way should I do it? I'm asking why would you have 2 scripts when you could have one and call out to awk and dpackage from your Python script?
That's what I'm trying to work out right now.
I don't think they're like, I don't know why you do that. It's just two scripts to manage then, and Python is perfectly capable of calling those commands and getting that output. So why would you separate it?
Well, I mean, you're still distributing 2 files, like with the SH, you still have to put that, but you're still going to have 2 files.
If you were really worried about that, so I'm almost everything that I'm working on, I have control of the environment, so I'll install the scripts that I need. I won't actually distribute 2 files.
Right.
But if you were really concerned about that, you could easily use like the subprocess.check output, and have pretty easily get that dpackage output, and it would be almost as easy as these commands that I'm showing you, if you just wanted to use the Python standard library.
And then,
Does that make sense?
no, it does make sense.
Do you want me to show you?
Sure.
Let's see what that was. What? Come on. Thank you. Dang. That's right.
What do we have
On
to
6.
decode?
Yeah, I'm just trying to figure out what's complaining. Price like application.
Requirements. And that makes sense. Like I said, I'm just trying to understand, like, I'm trying to imagine where I would apply this and how.
I mean, if you end up doing shell scripting, which I'm a programmer, so I like to automate things.
Sure.
And there's sometimes when it's hard to get the input or output, whichever way you look at it, for a certain thing I'm trying to do from within Python itself. And it's really easy to shell out. I know how to get the command, so I might as well just shell out to it, get the command, get that output in Python, and then do whatever I want with it.
Right.
So I do that rather frequently.
Good stuff.
Yeah, I think there's some situations that I've been in where I've had to sift through a bunch of files on the server somewhere and, you know, extract like certain fields out of, you know, just a bunch of junk where I have to do a bunch of bash food. And situations like this, if you have Python, kind of lets you leverage those, you know, those shell programs. But also when things get really finicky, like when you're trying to do things that would be really easy to do with list comprehensions or raw, like Python.
I mean, who wants to use awk, really?
Right.
Does anybody really want to use awk?
No, and I think that's what the big takeaway is.
We do a lot of similar stuff to this in our area. Working with Hadoop, we're sitting there using the HDFS command line tools and scoop and things like that. And especially like our data scientists will go through and kind of like bulldoze their way through to get into the model they want or something, and they'll hand over a variety of bash and shell scripts and stuff that they've done with Python sprinkled in. And when we take those back to our actual like Python master system, we begin to use subprocessing to take their work and gradually refactor it and pull pieces in and integrate them into test and deployment stories. And that way we can work with what they've already got, get that integrated, get it tested, get it deployed, and then we can begin to refactor what actually makes sense to be in Python instead of like bash or shell script into the Python system. So it also gives you that flexibility of, okay, somebody's done all this work over here, instead of trying to redo all that work at once, kind of doing pieces, and because Python you can use the subprocess and the OS module and everything to not tackle that in one change.
It's not only about shell scripts, right? Anything that runs from the command line gives you standard out. Anything at all.
Yes.
Right.
I'm using shell scripts
it's a
really
great way
broadly as system commands is really what I mean.
I mean, if you have an application like way back when we use IBM ClearCase, right, which is their source code repository. If you want to query something about the source code repository, you can run a command line ClearCase, right? I'm sure Git has the same thing, right? Git is a command line program, right? Can be run as command line. It is. So if you want to query something, if you need an automated script to query something about to Git, you could use these same sort of things.
That's
you
actually
call to Git, pull the data into Python and manipulate it however you want.
So this was a script that one of our former developers had developed to kind of release Python packages that go to PyPy. And so he's got a bunch of Git and Python, and this is all just a big bash script. This is actually where I got the confirm thing. And so I was converting this to Python because there's some other release, deploy, provision-oriented tools that I would like to just kind of have all in one place. And I hate bash. I don't know what's going on. It's taking me forever to figure out what some of this stuff's doing, and I don't want to look at this. I'm a Python developer. I've got Python. I use Python every day. Everybody in our team uses Python every day. You know how many of us use bash?
And by converting a lot of it into Python, you then, all the people on your team that don't know bash, right?
Yeah, that's right. Everybody.
They are able to now maintain it.
Yeah, exactly.
Instead of having people that know bash.
Yeah. Like I don't want to use this bash script and have it somewhere and have everybody have to know bash in order to change it or update it. Then it becomes kind of the bottleneck where the only person that's going to touch it is the person who really understands bash. Well, I have a Python shop. Let's do it in Python.
Yeah, I know bash, but I mean, I'd like it if everything was in Python. It's easier to follow anyway, too.
The only downside maybe like if you want to ask about grep, if you want to process really massive amount of data,
That's
then
true.
this approach will kill you. I mean Python, yes, and Python bash will be pretty fast.
Yeah.
So, but probably will have.
Although I wonder if you did the sub process, if you did sub process and passed the pipes to each other, I wonder if that wouldn't all stay in C anyway with the file descriptors and maybe it wouldn't. I don't know.
Well,
I'd experiment first with Python and see how it goes. But if not, then you write a little bash script that does the pipe or whatever, and then you use that from Python. So if you're working with really, really big data anyway, you're already probably used to what are the commands I'm using for big data, and then what's the Python I'm using to glue it all together. So because everybody knows if you're working with a lot of data, Python's going to be slow. If you're doing everyday scripting, most of the time it's going to be plenty fast.
Yeah, that awk command would chew through a lot of data pretty quick, but it was comprehension with the if at the end would be yourself. Comparatively.
All right, well that's it. If you want to leave, head out. If you want to stay and talk, I'll probably stick around for just a little bit.